My name's Alan. I work in the Forever Smiles Dental Lab. I'm the head of being cool and good at stuff, and this is where smiles are made. All right, so the beginning of the Forever Smile process on the lab end starts with scans of the patient prior to surgery, and then we pre-design an arch for them. This is like the moment the patient sits down. Before surgery starts, and then we load in this pre-design, and then towards the end of surgery, we get sent our sutures, and then we line that up with an implant position, and that all gets merged in with that pre-design we made in the beginning, and we get our final restoration. Typically, we're designing during the surgery. We get sent that first set of scans right before surgery starts, and then we immediately start the pre-design. And then usually we finish up a little bit before the doctors. So we hang out for a bit, wait for implant positions and our final suture scans, and that all gets bundled together.
So what is the benefit of being able to do this in-house compared to what you think another company? Because you can kind of make adjustments on the fly and reprint the set if needed, like the same day?
Yeah, so we can, within a day or two, make a completely new set. For some reason, patient isn't happy, whether it's like aesthetics or a comfort issue. So we know that this is going to fit. So the traditional, like, made at another location prior to surgery ones, typically they don't know exactly where the implants are gonna be. Like here, we get a super accurate implant position scan, and because that's laid into this, we know this is gonna drop right in. No adjusting, no like fiddling with the patient.
You're talking about like alginate impressions? Is that what you mean?
From my knowledge, like the old school way, really the main way to do it is to take impressions prior. A lab is gonna make a denture, and then day of surgery, the doctor is gonna cut holes in the denture where the implants are and convert it into an implant restoration. So this instead is like purpose made to be an implant restoration. And again, like because we design it after the implants are placed, we know it's accurate and it's gonna pop right on.
That is so cool.
As also, you know, guarantees that the implants have the best chance of healing and integrating because they're not being pulled every which way by an ill-fitting restoration. Once the restoration's all done, so we have our nifty little printing software. We throw it into our slicer. This is the software for the printer. We nest them on a little digital build platform. And if we take a walk over to the printing room, these are our Sprint Ray Pro 2s.
Trade secrets. We're gonna learn that.
That's sick.
Yeah, these are awesome. They take about 20 minutes.
That's it.
Yeah, super strong, super durable resin. Fastest printers with the strongest resin. So I said print, and then in 25 minutes we'll have a full set of teeth. Like, you know, like when people film and it's like from like a low shot and like flips up and it's like a jump cut to catching it. It's a couple $100 a bottle. It might not be, maybe it's like it's in multiple hundreds of dollars.
Proprietary pricing, yeah. Now that Min's not here, you can kind of say you're the director of the lab.
And that's Min, right? Min does that. I met Min. Min's the main man there, man. Min is the man.
Yeah,
I'm lab director.
I'm the head of being cool and good at stuff. And this is Mr. Yao, one of our designers.
Hi, Mr. Yao.
How you doing, Mr. Yao?
So you guys do the same thing though, like modeling, right?
Yeah, so Mr. Yao primarily just designs. Yeah, and Nick's actually in the middle of a DOS right now also.
What is DOS?
Day of surgery. So that's the ones that we produce while the patient's in the chair.
Okay.
So he's actually doing corrections. So sometimes we decide we need to make some changes to the bite. So that's usually next day or 2 days later, depending on when the patient wants to make it back. But I mean, so this is actually a good example of this is how it comes out of the mill. It starts as a big brick of like chalk that gets cut out into this shape, and then it bakes in an oven and it hardens.
And what material?
This is zirconia.
Zirconia.
And then this is one that's kind of halfway through the process. So gingiva's there. It just doesn't have the teeth glazed yet.
That is wild.
These guys as well, these are like halfway through the process. These are the...
And that cures the enamel?
Yeah, these are the glazed ovens.
Glazed
so
ovens.
these go up to 710 Celsius.
Wow.
That's what bakes
Pizza.
it on. Yeah.
Like mini pizza.
Very burnt pizzas.
That's awesome.
It's like pottery. It's pottery class in here. It's very strong pottery. This is gonna be the hardest room audio-wise.
You'd be surprised.
Oh, this is actually perfect. Zirconia starts as a raw puck. So it's soft, it's like chalky. And it goes into a mill. So these are 5-axis mills. And a little burr goes around and cuts it out, follows instructions from the design that we made. And then this gets cut out, we clean it up a bit, and it goes in a really big oven over there that it's kind of on the other side, on the other side of that glass.
Wow.
We can check out the ovens in a second. And it bakes and it shrinks down, I think it's about 20%.
When it bakes?
Yeah.
So you gotta print it larger?
Yeah, so
What?
So we design it, and then we put it into a milling software, which each puck has like a known shrinkage factor.
Oh, so it compensates automatically.
Yeah, so it scales it up to match the shrinkage factor. And then we mill it out, we pop it in the oven, it shrinks down. And it's honestly, the accuracy is insane. Like,
Do you know like the tolerance, like millimeter wise? Is it like, I don't know if you guys have like a standard it has to butt up against,
it's pretty tight, so honestly, they just drop right on.
and that's it?
Yeah, that's what's crazy about it. Like, you know, all this data that gets put into it, like we get the implant positions, we design everything, we have to scale it up, and then we have to physically shrink this back down. And somehow, everything is just so precise.
It's just like one-to-one. The scan is so accurate, the print is so accurate.
Yeah.
It just translates over. That's sick.
Yeah, so every step of the process is so dialed in that at the end, there's no fixing that ever needs to happen. Everything is right where it needs to be. So these are our baby sintering ovens. These are where like the single crowns go in. There's no arches in them right now, but this is all just one big oven that a little like crucible goes in. It goes up and it cooks for 14 hours overnight.
What? You
Yeah.
guys leave here with that running?
Yeah.
That's crazy.
On it. When
I'd have that in a room like outside somewhere. You know?
When we get new ones, it's like it takes you a minute to trust it.
That's
Like you start it like halfway through the workday, and you're like, okay, it's been running for 6 hours. There's no way it's gonna set up.
I left the oven on. I think that's what I'm thinking of.
Yeah, these are definitely the main holdup in the beginning of the process, just because of how long it takes for the oven. And then the other part that takes a long time is the finishing work. Is somebody sitting down with a brush and
How long you think? Like 6 hours?
of like total like labor being put
Yeah.
into it, like 6 hours, but there's gonna be like 3 to 5 oven cycles included in that.
Oh, so you got to do a little bit, then cure it, and then do it more?
So we do like 3 to 5 layers depending on the arch we're making, and each oven cycle is about an hour.
It's like painting, like layers of paint pretty much.
It's very similar to the glaze you put on pottery. So like pottery, you glaze it, you put it in the kiln, and then it's gonna be hard after. Very similar.
No, it's good to show the process because people, you know, they don't understand how much goes into it. So
Yeah, definitely.
that's awesome. Dental lab, baby.